Good morning. Advent of Code 2022 is finally upon us in 10 minutes. And I've had a thought about how to do day one a bit more quickly. I've noticed that for the last couple of years, the day one problem, the input has always been a series of integers in a file. So I can just write the code to pass the integers straight away. And in fact, let's have these as a grar. And I'm pretty sure that that this is going to be exactly what I want for day one. Let's make a gr of the nums. And then I think turn it into just a normal array. And then I'm looking at the answer as well. And then when I've got the puzzle, I just need to fill in what goes here, hopefully. That should be that. Cool. And the other thing I thought was, for the last couple of years, it's been possible to solve problem one having read only the last line of the problem statement. So the plan is, grab the problem statement using the program, just read the last line, think about it, while the input is being downloaded, write this, run the program, submit the answer, first place. So just got a few minutes to wait. Actually I should, since I've got a few minutes, I can check that this is correct. So this will sum up the numbers in the input. 10, 20, 25, 125, 830. Okay, good. That hasn't worked. Good job I checked this thing. Oh, I see. I put numbers equals grid base nums instead of grid base gr nums. Very good. But at least that means don't need to do that debugging on the clock. The watch face I'm using at the moment on Bangor.js doesn't show seconds, so I'm having to look at my Linux computer clock to know the exact time. Actually, we can also check that this is going to work, can't we? Ah, it's not working. That's classic. Okay, good. So that's what I'm going to want to run once it's 5 o'clock. So yeah, for subsequent days, maybe I'll run a different watch face on my Bangor.js that shows the seconds. Also, it might be useful to get into the habit of timing how long the program is taking to run because I recall that if the program takes longer than about 1 minute to run, then I'm better off compiling it and running the compiled binary than running the interpreter. Actually, that 2021 problem statement looks wrong. Oh no. I'm going to restart the Linux side of the Advent of Code proxy. Oh no. Oh, I know what the problem is. Oh yeah, that's fine. It's because the Advent of Code thing writes to standard out and to standard error. So of course you get 2 copies of everything. Phew. Got 20 seconds to go. Alright, good luck everyone. Oh, my fingers are cold. This is bad. Alright then, what's the last line say? Calorie counting. How many? Okay. So I cannot use my template. So sum up these blocks. Which block's the largest? Is it just asking for the largest sum? Looks like it might be larger than 16 bits, which is annoying. Say, find how many total calories. Okay. Do. Plus, oh yeah, there's no plus equals. Oh, I haven't got. Yeah, it needs to be a big int, doesn't it? Pretty sure it needs to be a big int. Not the right answer here. Sum is big mu of 0. Answer is big mu of 0. If big sum W sum, that's my line, big print. Oh well, there goes my plans of first place on the leaderboard anyway. Ah, no. 1, 1. 1051 2165. That's also not the right answer, okay. Oh, I forgot to reset sum, didn't I? Derp. That's not right either. Oh my god, this is it. Okay, let's try that then. Yeah, good stuff. Cookie for part 1. We want the combined sum of the largest array. Is it big clone? No, just big new. No, big clone. Yeah, okay, fine. So we'll push that on sums, and then we'll want to sort the sums, and then we'll want -1, -2, -3. We're resetting the sum after each one. We're adding each sum to the sums. Grar. We're summing up the 3 final ones, and then we're printing them. Not the right answer. Oh, oops, no right. What? 45? Three, 6, 9. Oh, 45 is the... okay. It's not playing the final sum. Which is also a bug in my part 1, but obviously the largest one wasn't the last one, so it didn't matter in part 1. How can they be negative? I wonder how many there are. It's slow because this is how slow big int operations are compared to ordinary int operations. It's spending almost all its time formatting strings. I remember the biggest was 67,000. Okay, I can't bother with that. But we did note that some of them were negative. But I don't see any negative numbers. Will I try to read from standard in? No. Maybe some individual lines were. No, they can't have been too big, otherwise part 1 wouldn't have passed. Looks like they all fit with it. 34,978. Okay, I see the problem there. So, in that case, so that number is negative. What we need to do is, I guess we'll just leak the memory. Big A to I allocates a big int. But since there was only like maybe 1,000 and something lines of input, I don't think that'll be a problem. Okay, let's try that then. And again, big int passing much slower than ordinary int passing. What I should have done instead is, since I'm pretty sure they're all smaller than 16 bits, I could have done A to I of line, treated that number as unsigned, but then used big add W in maximums of 32,767. And this is a case where, although the runtime of the program is well over a minute, I don't think it would be worth compiling it and running the compiled version, because the slow part is all inside big A to I, which is already compiled. I haven't been timing how long it takes to run these. I wish I had an idea of how far through it was. I'd know then whether it's worth doing the 32,767 thing. In fact, I'm going to do it. Oh, but I can't kill it until it makes a system call, which will be the next time buff.io tries to read a block. Okay. So n equals a to I line. If n is greater than 32,067 unsigned, I want to add to the sign 32,067 and subtract that from n, and then add what remains. In fact, if that said while n greater than 32,767, oh no, because it can only be greater than once, can it? Is that the same number I already submitted? Not the right answer. Is not correct. Oh, yeah, it might be correct. 32,768 times 3 plus 4 plus 3 plus 2. Yeah, that is correct. Interesting. Let's read the problem again, because maybe I misunderstood. By the time you calculate the answer to the elf's question, they've already realised that the elf carrying the most calories of food might eventually run out. To avoid this unacceptable situation, the elves would instead like to know the total calories carried by the top 3 elves carrying the most calories. That way, even if one of those elves runs out of snacks, they still have 2 backups. In the example above, the top 3 elves are the 4th elf, then the 3rd elf, then the 5th elf. The sum of the calories is 45,000. Find the top 3 elves carrying the most calories. How many calories are those elves carrying in total? Well, I think I understand the problem correctly. So what am I doing wrong? Let's have this back and see what it says. Oh, at least they're not negative now. Okay, that's going to be wrong. Here's 841 simply in the input. Or can we otherwise find the... It's quite a big input for day 1. Can we find the one that sums to 841? No, there is not one that sums to 841. So, where does that come from? That's bad. Well, that seems to be proceeding as expected. Why? Okay. So what I want to know is, if the sum is 841, what did we just add to it? The idea being, if we can track down why one incorrect sum is being created, maybe we will find the bug. Ooh, okay. What? Oh, equals 0. Oh. Oh. Oops. I'm wondering if that was actually a line that contained 32,067 plus 841, which is 33608. There's a line that's larger than 16 bits. Oh, really? Do we have to pass a big int for every line? No, I'm going to do another bodge. It's the length of the line is 5. And if line 0 is greater than 5, and we'll add 50,000 to the sum, and subtract 5 from the 10,000s place. Delicious. My screen's just locked. I wonder if that stops the recording working. So that hasn't worked, has it? Because the Strelin of line will be 6, because there's a new line at the end. Oh no, don't print them all out, I forgot about that. Yay, great success. Part 2 cookie. Maybe the cookie's slightly too big to try to eat in one. Anyway, this step is quite hilarious. It's a lot faster than trying to pass big ints. However, my usual problem of writing complicated code that's fast and incorrect instead of simple code that is slow and correct. I'd have been better just passing it all with big ints from the first place and waiting for it to run. Never mind. I'm curious to find out whether it runs faster, how fast it is to compile and run versus just running the interpreter. So that's 5:33 exactly. Oh. And part 1, I should have been able to do more simply. I think I was too keen to try and get a good time, and that ended up costing me time. So compiling took 35 seconds, and running the compile binary take from 3406 to 3422, which is 16 seconds, for a combined total of 51 seconds with the compiler versus the interpreted version only 28 seconds. So I was right to be using the interpreter rather than the compiler. So that's good. Anyway, that's all this day 1. Didn't go as smoothly as I would have liked, but thanks for watching. Goodbye.